two very important ideas within the subtopic of functions is that of domain and range. The domain refers to the set of all possible input values, while the range refers to the set of all possible output values. For a lot of functions, for example, this one, both of those values, the domain and range, will be the real numbers. Okay? Range can be restricted by vertices or asymptotes. But we want to focus here on domain restrictions. And there are three conditions that can result in a domain restriction. The first, if you have an even surd, most commonly square root, you cannot evaluate the even surd of a negative number. What does that mean? It means that if this value here is less than 0, we don't have a solution. So 2x minus 6 must be greater than or equal to 0. And if we solve that inequality, we get that x is greater than or equal to 3. In terms of range restriction, well, that's going to have an impact on the range. The range of this function, if x can only be 3 or above, then y has to be bigger than or equal to 0. If this were a negative function, then that would change that to less than or equal to. So hopefully you're starting to see that range restrictions can be a bit more complicated, and you need to think a bit more logically about the function. Alright, but the range restriction, because this is a positive function, would be greater than or equal to 0. Let's have a look at that on the GDC. That is what we see. This value here, if we want to know what it is, trace... Actually, let's look at analyze graph and find a 0. So go left, right, there it is, 3. X does not exist below that value of x equals 3. The function does not exist below y equals 0. So that range restriction of y being greater than or equal to 0 is true. Now what I was talking about before, if this is a negative function, have a look at what happens. The domain restriction doesn't change. But this now being a negative square root function, it's been reflected across the x-axis, and so we see that the range has to be less than or equal to 0. Second example is where you have a rational function. So you have a denominator. And what that implies is that you cannot do 1 divided by 0. And so for a rational function like this, to restrict the domain, we go x minus 3 cannot be 0. So x cannot be 3. How we usually write that is x is an element of the real numbers where x cannot be 3. But this would be acceptable. In terms of the range restriction, for a rational function such as this, it's the highest order term from the numerator, 5x, divided by the highest order term of the denominator, which is x. And so we get that y cannot be equal to 5. Let's have a look at that function. Here it is. 5x over x take 3. Let's check those domains and ranges. So go menu, graph entry, edit function. And this is where we type in our domain restriction of a range restriction of y equals 5. Yep, that looks correct. And to type in our domain restriction, we go Menu, Graph Entry, Edit Relation, and type in x equals 3. And that appears to be that asymptote as well. The third domain restriction that we're interested in is if you have a logarithmic function. You cannot take the logarithm of 0 or a negative number, the implication being that the argument inside the logarithm has to be greater than 0. Not greater than or equal to, like for a square root function, greater than. And so we end up with this. Alright, so if x is greater than 3, what's y greater than? And that's a little bit more difficult to determine here. Let's have a look at that function. Trace. And let's type in x equals 3. And we see that it's undefined. So x is greater than 3. However, if we think about the range here, the actual solution to a log can be 0, it can be negative, it can be positive. So this is not an endpoint, this is an asymptote. Okay, and the range is going to be real numbers.